Hi guys. So what we're going to be doing for the next couple weeks, we're going to be going through and doing some problems out of this packet thing. It's called the stoichiometry packet. We're just going to be doing the beginnings of it in this unit. Later on in the year, we'll do a bunch more stuff. So the assignments for the next basically week and a half are going to be just taken directly from this. Where there's going to be, I'm going to show you a page. It's going to have a specific problem type on it. We're going to go over it. I'm going to show you some examples, and that'll be that. All right, and we'll go through and we'll do it all. Now, it's easier said than done. Some of these are easy. Some of them definitely get complicated and confusing. This first one, I'm going to explain quite a bit about this because you haven't seen any of this before. I got to talk about the way you're going to do the problems and all that. The rest will go much faster. This is kind of also just like an introduction video to how we're going to do all of this stuff. So what we're doing now, first, these pages, they have two numbers at the bottom of them. They have this number 9 thing here, which we're going to not worry about. And they have an SP, and then they have a dash with a 9. That's one we care about. They're not all exactly the same. So that's why I'm going to be referring to them by this number. All right, just so you know. So what we're going to be doing right now, we're doing moles of elements. But basically, we're going to be doing one-step conversions is what we're going to call these. So this is SP9, all right, and then this is one step. Conversions. So to do this, if you look at the beginning of this packet, this file, this little packet thing that you're downloading, it has this available. There's this mole diagram. All right, this is a good thing. This is crazy useful, ultra crazy useful. You are going to want to reference this a lot. All right, this will help you do everything. So what we're going, and I'm going to talk about this for a little while now. So what we're going to be doing, you'll notice that there's moles in the middle. Now moles are, again, it's this thing where, remember, the mole is this thing that allows us to relate the mass of an element to the number of particles that are present in the element. Remember, we said that 1 mole is equal to 6.02 times 10 to the 23rd atoms. It's a big number. And that we also said that a mole of carbon is equal to this, but it's also equal to the mass. So that's cool. There's actually even another value that the moles are equal to, which is the volume of a gas of an element. There's this constant number that the mass, the volume always is, which we'll talk about not today. But the idea, though, is that the mole is kind of like this unifying thing that allows you to convert between things really nicely. And this chart is really helpful in showing you how to do those conversions. So we're going to be using just this part of the chart right now. We'll talk about the volume not today. So basic idea. Here's the basic idea. Anytime you're just going to be using this chart to sort of diagram problems that you're going to want to do, conversions and examples of problems that you're going to want to do. So let's say that you start with something really easy. Let's say that we have 5 grams of carbon, and we want to convert that to moles of carbon. So this is an example. So we got 5 grams of carbon. We're going to convert that to grams of carbon, or 5 grams converted to moles. So, all right, first, grams. What the heck is grams? Well, look on this little chart. Grams is a mass. So you're going to want to write on here that grams is a mass. All right. Now, you'll notice there are little arrows telling you stuff. So we're going from grams to moles. So that means we're going from mass to moles, grams to moles. All right. Now, this tells us exactly what to do. It's really cool. It says, hey, divide by this thing. And you're like, what is the gram formula mass, gram atomic mass, blah, blah, blah. This is a really fancy way of saying the atomic mass, or the molar mass, or to be even more specific, or I guess less specific, or in general, this is the periodic table mass. So what that means, actually, I don't want that to confuse you. I don't want you to think that this has anything to do with this. So this here, this is the period. Yeah, I'm just going to cross off. That's going to confuse everybody. So this is the periodic table. All right. This thing here, this value is from the periodic table. So you're going to divide by the mass from the periodic table. So you're going to do 5 grams of carbon divided by the mass of carbon from the periodic table. All right. Now, as far as writing this all out and setting it all up, let's talk about that, because that's the part that's going to be the most frustrating or confusing potentially. I'm going to expect that it be set up and written out like I'm showing you here. If you do not write it out like this, you do not get credit. You do not pass the end. That's simple. All right. I'm very lenient about a lot of stuff, but not this. You need to do it this way, or else you are going to fail. Honestly, you're not going to be able to handle the stuff we do later then that requires these conversions to be done a certain way. All right. The math is simple. It's not about the simple math. It's about writing it out properly and showing the work properly so that later when we get down to harder stuff that you can do it without issue. Okay, that's why. Just so you know, so that's why I'm going to be like not very nice about grading stuff. So anyway, you're going to write it out like this. You're going to write 5 grams. You're going to write C. So 5 grams carbon. All 3 of those things are equally important. It is no longer just the number. It's 5, it's grams, it's carbon. Without any of those 3 things, it's a useless, meaningless value. 5 by itself is useless. Grams by itself is useless. Carbon by itself, useless. But 5 grams of carbon, that means something to us. You're going to draw a little thing like that now. Remember that from dimensional analysis and unit conversions? Yeah, it's back. Now, all right, now, the next thing. Remember, hopefully we remember, whatever value we put up here, whatever units we have here, you copy them down there automatically. Remember, whatever you have in this spot, you put down there in that spot, always. So you copy grams down to there. Now, what are we trying to get to? What does this problem want? Problem wants moles. So we are going to write moles. I'm going to abbreviate it MOL. That's always how we're going to abbreviate it. We're going to write moles of carbon up here. So you do that. Cool. And then now you're like, all right, what numbers am I writing? What the heck am I putting in here? And it's like, okay. So how do you do this? Well, for mole, you're always going to put a 1 in front of mole right now. Next semester, later on, that's not going to be the case. But for right now, that's the case. So 5 grams of carbon, 1 mole of carbon. All right. Is that so? We got 5 grams, we got 1 mole. So the 1 always goes with the mole. Now, what am I putting for carbon there? What is our mass of carbon? So remember, we're dividing by the periodic table mass. All right, this is all a fancy way of saying from the periodic table. So the mass of carbon on the periodic table is 12.01. Right. So 12.01. Now remember, if the numbers, one number's on top, the other number's on the bottom, you're going to divide. That matches with what this says. You're dividing, so you're going to do 5 divided by 12.01. So 5 divided by 12.01 gives us, I will say, 0.42. Okay. 0.42. Now, units are equally as important. You're going to cancel out grams of carbon. You're going to write moles of carbon, because that's what's left. You don't write moles of carbon, the answer is not right. So to be clear, what do I expect you to write for every problem? I expect this, everything in this box. You don't do all that, you don't get the points. It's that simple. All right. Again, normally I'm a little bit more relaxed, not this time. So now let's do another type of problem there's several example problems we got to cover here. Like, sadly, this is not just a simple one-off thing. Like, there's a bunch of stuff we got to talk about. So now that's grams. Now to just do another one where we go in the reverse direction really fast. That's all we need to do today. And then we'll talk about atoms and molecules and stuff. Let's say we have moles of carbon. Let's say we're going to go now. We're going to say we have 3.2 moles of lithium, and we want to convert that to grams of lithium. I'm going to go a little faster through this one. Just letting you write stuff down. I feel like I need to be patient and wait sometimes. So in this case, we're starting with moles of lithium, and we're going to grams. So we're going from moles to grams, moles to mass. So this means we're going to multiply by the periodic table mass. So we're going to multiply by the periodic table mass. So same setup, 3.2 moles of lithium, moles of lithium. Remember, whatever you have there, you copy it down there automatically. So this just gets copied automatically, no thinking, you just do it. Our goal is to get grams of lithium. So get grams of lithium. Now, numbers, remember, mole always gets the 1, always. Wherever mole is, you put 1 there every time. You are going to multiply by the periodic table mass. So lithium's periodic table mass, it's right there, it's 6.94. So you're going to do 3.2 times 6.94. That gives us, let's say, 22.21. We'll round up grams of lithium. These will cancel. So there's another example. Now, what if sorry, I thought I had a piece of paper and I wrote some more stuff down. Oh, there it is. I was looking for that. So now, let's do more examples. Now, what if you have a problem? It's a little different. This is where I'm going to lose some of you, get you confused. So pay attention, focus on this part. Now, what if you have a problem that says this instead? What if you have a problem that says So this is something you're going to see now. This is where I don't want you to be confused. What if you have 4.7 times 10 to the 23rd atoms of beryllium, and you're going to convert that to moles of beryllium? So you see this, and you're like, oh, scientific notation. And you're like, all right, well, don't be bothered. It's all the same stuff. Pay attention to your details. So on this whole chart thing here, where are atoms? Down here. These are particles, all right? Particles, representative particles. Atom is a particle. So you find atom down here. You want to get to moles, all right? It tells you what to do. You go up, you're going to divide by this number. This number is called Avogadro's number. So that's the mole value. That's where that 6.02 times 10 to the 23rd came from. It's called Avogadro's number. And it means, for every 1 mole of something, you have that number of atoms present. So you're just going to divide by Avogadro's number. Now this number, this doesn't change. This does not change. That's the fanciest N I've ever written. Look at that. That's like a fancy cursive, like super nice N. But it doesn't change. It doesn't matter what element you have. It's always 6.02 times 10 to the 23rd. Always. All right, so the setup is the same as these other problems. you're just going to take your number. And you're going to do this. All right. So you're going to take your number. You got atoms and atoms. You're going to copy down whatever you write here. That should just be pretty like automatic now. Moles of beryllium goes up here. Now, what are we doing? Well, remember, moles always gets the wood. And then this also tells you you're dividing by Avogadro's number. You're dividing, and that goes on the bottom. So just put it in there. And you're going to do your math. You're going to do 4.7 times 10 to the 23rd divided by 6.02 times 10 to the 23rd. All right. So we'll do 4.7 times 10 to the 23rd divided by parenthesis. Please type Avogadro's number in parentheses when you're dividing. Otherwise, you're going to get it wrong. Like, you will get it wrong every time if you don't put in parentheses when you're dividing. All right, you will always get it wrong. Don't get it wrong. Parentheses. If you want, you can also program. I always program A to be Avogadro's number. Remember, you use that store button on the bottom. If you need me to show you that, just send me an email again, and I'll show you how to do it. This is what you're going to need a scientific calculator. You haven't figured that out, you're going to need a scientific calculator or graphing calculator. So anyway, so we got our answer. We'll just write it 0.78. So you'd write it like that. You would cancel out atoms. And there you go. All right. And then last but not least, let's do the final type of example for today, where you're going to be converting the other way then. So where you would be converting from moles to atoms or to particles. So let's say we've got 7.2 moles of sulfur, whatever. We want to convert to atoms of sulfur. Well, this idea is pretty simple. You're just doing the same thing. You're starting with moles. So you got moles. You're going to convert down to atoms. In this case now, you're going to multiply by Avogadro's number. So you're just going to multiply by Avogadro's number by 6.02 times 10 to the 23rd. So you got moles of sulfur. Remember, you're just copying stuff down. All right, just transfer this moles down to there. 1 mole is equivalent to 6.02 times 10 to the 23rd. Remember, we're always putting 1 for mole, and the thing told us we're going to multiply by Avogadro's number. So in this case, you're just doing 7.2 times 6.02 times 10 to the 23rd. You're going to see this answer in your calculator. In most of your calculators, it's going to look like this. I don't want you to be confused. Understand that means 4.33 times 10 to the 24th. That E means times 10. So it's times 10 to the 24th. So 4.33 times 10 to the 24th. Cancel your units out. Atoms of sulfur. So that's how you do SP 9, the very first assignment here. It's a lot of examples. You're going to want to pay careful attention to all of this. Pay attention to what you're starting with. You start with atoms here, but then you switch to grams, and then you're doing something different. So pay a careful attention. Look at the directions. You're converting to moles. So you're going to do atoms to moles. So you're going to look at the chart. You're like, boom, I'm going atoms to moles. Now these first ones are pretty simple, they're pretty simple. But then as you get further along, they get a little less easy. And remember, to get credit, to receive credit and be correct, you got to show all of this. Everything in there would get you credit, full credit. Otherwise, it's pretty much you ain't getting nothing. You write the answer down by itself, you get nothing. Absolutely nothing. I think I've made that clear throughout the year. So that's the first set. There's also videos from my previous class on there as well if you need more help.